Okay, let's kick off this deep dive. We're looking at an indicial equation. It's 4 to the power of 2x plus 1 equals 32 to the power of x minus 1. So the unknown, our x, it's trapped up there in the exponent. Our mission here is to find the quickest, most, elegant way to solve it.
And right away, what's so interesting is how deceptive it looks. You've got these two very different bases, a 4 and a 32. The whole trick really is to get them to speak the same language. If we can unify that foundation, the whole thing just collapses into a simple linear problem.
That's step one, right? Finding the common base. It's kind of like trying to compare different currencies. You can't really compare yen and euros directly. You first have to convert them both back to something common, like the US dollar. Our dollar here is the number 2.
Exactly. 4 is just 2 squared. And 32, well, that's 2 to the 5th power. Just recognizing that, just that simple fact, changes the entire equation.
So we substitute those back in. The equation then becomes 2 squared, all raised to the power of 2x plus 1, equals 2 to the 5th, all raised to the x minus 1. Now, lots of people might rush to logarithms, but this is so much faster. Why?
It's all about the power rule. The index rule that says when you raise a power to another power, you just multiply them. So on the left side, we multiply that 2 by the entire term, the 2x plus 1. You have to distribute it. And that gives us a new exponent of 4x plus 2.
Okay, I see. And then on the right side, it's the same idea. The 5 gets distributed across the x minus 1.
Yep, which leaves you with a new, much cleaner exponent of 5x minus 5.
Yeah.
So our whole equation now reads 2 to the power of 4x plus 2
Right.
equals 2 to the power of 5x minus 5.
And that right there, that's the breakthrough moment. Since the bases are identical, they're both 2, the only possible way for this to be true is if the exponents are also equal. So we can just, ditch the bases.
You just equate the exponents, forget the 2's. You're left with 4x plus 2 equals 5x minus 5.
I mean, we've taken this complex-looking exponential thing and boiled it down to basic algebra. So now we just solve for x. I'll subtract 4x from both sides. That leaves 2 equals x minus 5.
In a final step, just add 5 to both sides, and that locks it in. X equals 7. Simple as that.
So the real knowledge nugget here isn't just a shortcut. It's that finding the simplest underlying factor, that prime number 2, let us convert an exponential relationship into a linear one. That conversion is everything.
It really is. And if we zoom out, it makes you ask a bigger question.
Uh.
What other areas of problem solving, maybe even outside of math, benefit from finding that simplest common ground before you even start? It's more of a meta skill, really.
Absolutely. The whole solution hinged on just one thing, recognizing that 4 and 32 were just different masks for the number 2. That simple recognition turned a tough problem into addition and subtraction. It's foundational.